Hi, this is Mr. Ward, here's Geometry Do Now 32.2 video key. And we have an equilateral triangle. A is equal to 2 ducks. And we are going to try and use the side length to figure out the area of this triangle. Now, typically, you'd use base times height divided by 2. So what would the area be? Well, the trick to this one is to remember that if you divide that angle, you're going to end up with 30 degrees here. Okay, so that's going to be 30. That'll be 60 still. And that is 90. Okay, and once we do that, we've created a 30, 60, 90 triangle. So that's A. That will be A over 2. And this will be A over 2 times the square root of 3. So square root of 3 times A over 2. And if we wanted to find the area of this triangle, what we need is this height and this base. So the base is A, and the height is A root 3 over 2. And you're going to do base times height over 2. So that's going to work out as A times A root 3 over 2. And then since the whole thing is divided by 2, we'll put another 2 factor in there. So this becomes A squared, or side squared, times root 3 over 4. So our area is going to be 2 squared over 4. So it'll be 2 ducks squared, root 3 over 4. And 2 squared is 4. So 2 squared and 4 are going to cancel out, and you're just going to be left with an area of the square root of 3. Okay, so there is a formula. It's going to be side squared, square root of 3, all over 4 is the area of an equilateral triangle using side length. Okay, and so therefore our area is going to be 2 squared, square root of 3, all over 4, which will be 4 square root of 3 over 4, which will just be square root of 3 ducks squared. Okay, and I'm going to move all that down so it's out of the way of that A over 2 that I drew. Boom, boom, boom. Now you can see it better. Okay, so that is the area. Square root of 3 ducks squared. Okay, based on all of that, we now have a hexagon. It's a regular hexagon. And if I drew all 3 of these diagonals, the main diagonals, the long diagonals, I should say, it divides it up into what you might notice are 30, 60, 90. It divides it up into equilateral triangles. That's 60. Half of 120 is 60. So each of these triangles are equilateral. So the overall area of this is going to be 6 times the area of an equilateral triangle. So 6 times side squared root 3 over 4. And the 6 and the 4 can be reduced to 3 and 2. And so we just need the side squared plugged into. So it's going to be side squared 3 root 3 over 2 times side squared. Okay, so side squared is once again 2 squared. So that's going to be 3 square root of 3 over 2 times 2 squared. And that's going to equal 3 square root of 3 over 2 times 4. And so the 2 and the 4 reduce into 3. square root of 3 times 2. So the overall area is going to be 3 times 2 times square root of 3, or 6 square root of 3 square ducks, since the side was 2 square ducks, or 2 ducks. All right, and one last problem for this 2 now. So we're going to be using Pythagorean triples to solve this. And I've listed a number of them. So a boat is tied to a pier by a 25-foot rope. There's your 25-foot rope. So that's in a diagonal, so that's a hypotenuse. The pier is 15 feet above, so we can say 15 feet. So currently, the boat is 25 feet diagonally and 15 feet down. Well, that 15 and 25, if you factor out a 5, you get 3 and 5. So this is a 3, 4, 5 triangle. So currently it is out 5 times 4, or 20 feet out, or 20 feet. So right here, this is 20 feet. And this is 15. So there's your 3, 4, 5 family triangle. Okay, so that's that. And now we pull in 8 feet of rope. So this 25 feet now gets shorter by 8 feet. And now this line is 25 minus 8, or 17 feet. Let's look at our Pythagorean triples. Oh, look, 8, 15, 17. And so now we got 15 and 17. And the new distance here, this is, of course, 17 feet. And this new distance here is going to be 8 feet. So how much did it move forward? It moved from 20 to 8 feet. So it moved 20 minus 8 feet. So 20 feet minus 8 feet equals 12 feet. So that's how much it moved. Hope that helped.